BC part of the exam. 60% of the exam is AB material, which is the reason why I go through all the AB material and review it. Justin, would you please sit down? Okay? So there's some new stuff here with sequences. Okay, girls? And it's on one of the questions on the free response. 3 are the common problems that AB do, and you guys do. You do the same one. And I've graded the BC ones. They're always better than the AB ones. And I've also done what they call the double bubble. There is one problem on the BC. Of the other 3 that remain, you have 2. One will be a vector. I can guarantee it. One will be a Taylor series. Sometimes they blend some of these things. Might put a differential equation in there. And then one will be, who knows, it could be polars. They have not had polars on a free response in a long, long time. Last year I fully expected a polar, and it didn't happen. Polars we'll do in April. They're not particularly easy. It's a different graphing system. But on the one of the problems of those 3, there will be a little piece that's AB, and the other half of it will be BC. That's how they get to the 60%. Well, how come we didn't get them before? Don't waste our time like that, because we have to get going here. Okay, our goals here. Understand the meaning of a sequence. Understand convergence and divergence. Those are new words. How to find the limit of a sequence. And then L'Hopital's rule. And hopefully we're going to get through all of this today, because I do have a day 2. And we'll prove some difficult things in day 2. You can go ahead and look ahead at it. And then day 3, I have some extra practice problems, and I don't know if we'll have a quiz or not. I don't know if I have one written. Of sequences. A sequence is a list of numbers written in a definite order. So we could talk about the sequence of natural numbers. You could talk about the even numbers, okay, girls? A sequence is simply a list of numbers. Sometimes I can see the pattern, sometimes I can't. It's usually a challenge to see the patterns. You will be asked to do some of that in your homework. We will be getting into series in the next section. Now, sequence and series, Justin, sound alike. And what we're going to do in a series is add up the elements of the sequence. And then we're going to have partial sums in the sequence of partial sums. So if the vocabulary is bothering you as I mention it, that's good, because that tells you you have to learn the vocabulary. So we're starting off with just sequences, just a list of numbers. There's a special notation. There's 2 ways to write it. You could talk about a function of x. This is a continuous. Equals x squared. That's continuous. There are no breaks in my graph. But when I do sequences, if I want a function of a sequence, I could write it this way. It says rather than, but usually we don't. But I could do the sequence of squares. So a sub n might equal n squared. So a1 would be equal to 1 squared. A2 would be equal to 2 squared. We always go up by ones. So this is what we call discrete. There are breaks. So it's a little different. Calculus usually talks about being continuous. I don't know why they call it calculus. There's not that much calculus involved. We're going to do a lot of the things like we did with integrals with summation signs. And A3 is equal to 3 squared. So I could talk about the list of the sequence of squares. And we can put these on your calculator. I can show you how to put them on your calculator. Okay. If a sequence has a limit, okay, that means the limit of my sequence is equal to L. We can write it that A sub n, I think that's written wrong. I think it's supposed to be A sub n, no, this is okay. A sub n approaches L, the nth element as n goes to infinity. When the sequence has a limit, it's said to converge. We're going to do a lot of stuff with convergence. Does my sequence of squares converge? You would have 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. No, this does not converge. So we say it diverges. and we're going to be talking about convergence. Sequences, you have to know the difference between sequences and series. Series are tougher to find when they converge. But the problem is, you have to know what's going on. What about a sub n is 1 over n, and n usually starts with 1. So this would be 1. What's the next element in my sequence? 1/2, 1/3, 1/4, 1/5, 1 over n, and what's the limit as n goes to infinity? 0. So this converges to 0. I'm going to do the limit of 1 over n as n goes to infinity is equal to 0. In fact, this has a special name. You need to know the special name. This is a harmonic sequence. And what's interesting is if I add up the elements in a harmonic sequence, it diverges. You're going to know this one really well. Okay, are we okay with what a sequence is? We're okay what convergence means. The limit of my sequence. You're going to be doing limits of sequences. Okay, let's see what theorem 2 says. And we have the squeeze theorem besides. If the limit of my function is L, assuming f is continuous, and I can model my sequence with this function. So for instance, let's let, if a sub n is equal to 1 over n, then f of x can be modeled with 1 over x. If I look at the graph of the sequence versus the function, here's the function. Remember what 1 over x looks like. We're always talking about positive values as well. I forgot to remind you of that. And then, what does the sequence look like? We start at 1, and there it is. And then we go to 1/2. Then we go to 1/3. So the sequence, those points will lie on that function. And what that theorem says is that if the limit of my function has a limiting value, then the limit of the sequence will also have a limiting value. So often, I might not know what a sequence does, but I might know what the function does. Because what's the limit as n goes to infinity of 1 over x? Look at your function. It's getting close to 0. We know that. We've done that a long time ago. Okay? So if my sequence can be written as a function like this one can, not everything can. We're going to be doing factorials. Can't do it. Okay? But if I can do that, then I can find the limit of the function, and that's the limit of the sequence. And our limit laws are on page 562. I'll let you look those up, but they're the same old limit laws that we've had before. And the squeeze theorem for sequences, which is on page 563. What it says 563. And you're going to put this into your little packet, so you're going to take notes there. Okay, if I have 3 sequences, I have a sub n, I have b sub n, and c sub n. And b sub n is trapped between these 2 sequences. Okay? Remember the squeeze theorem? It's just like that. And it says if the limit as n goes to infinity of a sub n has a limiting value, and if the limit of as n goes to infinity of b sub n has the same value, not b, I'm sorry, c sub n has the same limiting value, what can you say about b sub n? It's trapped. These guys are coming in like this. Some dots here. And then c sub n is this. Okay, so that's c sub n. This is a sub n. Then b sub n is trapped in that neighborhood at least. We make them x's. What can you say about the limit of that one then? It's the same. And so that's going to be hard. You have to figure out what it would be trapped between. So when we did the squeeze theorem before, it's very similar. And there it is. I just wrote it all out. that okay? Remember the squeeze there? And then there's theorem 4. These all match on your study guide. You might include an example. The purpose of the study guide is to help you get through this chapter. These are the important things you have to know. And this says if the limit of my absolute value of 0, absolute value of the sequence is 0, then the limit of the sequence without the absolute value is also 0. So if I take this sequence, maybe it does this. Okay? And I can kind of see what it's doing. But if I absolute value that sequence, then this would be here still. This would be up here. This would still be here. This would be there. So if the absolute value of my sequence approaches 0, not any number, 0, has to be 0, then the limit of the original one that's oscillating back and forth will also be 0. So be careful with that. Just because the absolute value of the limit might be a number, that doesn't mean that the limit of the one without the absolute value is that same number. It only works for 0. I'll be redundant here because even I fall into that trap. So there's a lot of memorizing learning to do. Okay, takes longer to explain than it actually does to do the problems. But you really need to do them, and we will probably be doing all the problems in 8.1 of the standard problems. I want to find the limit of that sequence. We could do it as a function if we want. It doesn't really matter. This is the limit as x goes to infinity. You won't change it, but I'm just going to do that for right now. This is a horizontal asymptote. Do you remember horizontal asymptotes? What is this getting close to? Not 0. 1. So you can do it the same way you've done before. When you look at n going to infinity, well, when n gets really big, this looks like n over n. So this is going to 1. That means the numerator and the denominator are basically doing the same thing. You may turn it into x. Most likely you won't. You'll just look at the sequence because I just want to find the limit. On the exam, it'll be a multiple choice question. They'll have 3 sequences, and they'll say, which ones of these converge? And then you're going to be going, oh, it's one of those 1 and 2, 1, 2, and 3, you know, those types. I hate those types. So that makes it harder. There's more than 5 choices in reality. But you're just going to look at it and you're going to say what it is. This next one is a little trickier because we have to look at the graph of this. The natural log of n and n. I think that helps to look at it. So let's look at the picture here. Do you remember what natural log looks like? Now, I don't care about this negative part. I just want to see it go to infinity. Natural log increases without bound. It is infinite. It doesn't go very fast. Like the log of 100 is like 12. It's not very big. What about y equals x? Because I'm looking at the natural log of x versus x. Which is bigger? The x or the natural log of x? X is bigger than the natural log of x. N is bigger than the natural log of n. So if you make things go big enough, if this is 100, then you're looking at the log of 100 divided by 100. Well, that's just 12 over 100. What's it getting close to? Use your intuition. It's going to 0. There's no work to show. Now, you might want to write that down. I'm going to use my magic pen because that's really important. Okay? We're going to use that later on. So there may be a place in your notebook where you want to keep some things that are really important. That's one of them. Because I'm going to come back and remind you. Well, I don't want to get rid of that. There it is. And we'll talk about their reciprocals because that's going to be important. But I'll do that later. Okay. You love L'Hopital's rule. Now, L'Hopital found out that if you want to take the limit of a function and you get 0 over 0, we always had to do some work. Remember, we factored or we rationalized. It was a pain. He found out that if you look at the slopes of these functions at the same place, that the limit of the actual function is equal to the limit of the slopes of the functions, provided that the original problem is 0 over 0. So do you remember doing this one? The limit as x goes to 0 of the sine of x over x. There's a whole bunch more pieces to love and cover. This is the basic one. Remember what the answer is. It's 1, right? Well, L'Hopital says, now, by the way, I want to stress this right now. If you get into the free response and it's L'Hopital's rule, you must write 0 over 0. You will not get the point, even if you do this. Usually we write L'Hopital, a little circle around it, saying we're going to use L'Hopital's rule. If you don't write 0 over 0, they give you nothing. I'm not sure I agree with it, but that's the way it is. So it's the limit as x goes to 0, and all we have to do now is take the derivative. If you take the derivative wrong, they will not give you the point. If you write derivative with respect to x of the sine of x, this is called declaring the derivative, and the derivative with respect to x of x, and then you do it wrong, like maybe you make it negative cosine, you still get a point, because we're clear about what your intention was. So, but I'm going to do it right. So this is equal to what? I'm hoping we do it right. That's my plan. Cosine of x over 1. You don't do the quotient rule. This is L'Hopital's rule. You take the derivative of each function and ratio them. What's the cosine of 0? 1. We knew that. So you could do that. It's very sweet, actually. You can only use it if you have a fraction, and it only applies to functions. So if you want to put it in as, we're going to get factorials, it will not apply to factorials. So if I do, just give you another one just quickly, and because we're not doing the practice out of the book on that one. As x goes to 2 of x squared minus 4 over x minus 2, we made you factor that. First thing you do is you write 0 over 0, because it doesn't apply. You don't get 0 over 0. And then you go L'Hopital's. I don't care if you write the L. I think it's kind of nice, but it's the limit as x goes to 2, and you take the derivative. What's the derivative of x squared minus 4? 2x. And the derivative of x minus 2 is 1. So what's the answer? Substitute it in, you get 4. And I don't remember if I taught you that at the end of the year last year. I thought I did, but it would have been like the day before the exam. You have to be careful. It's for indeterminate forms. There's a lot more than where we can apply it. But you have to have a fraction. You have to have 0 over 0, or you have to have infinity over infinity as far as you're concerned. Then L'Hopital's rule applies. Okay, there's another theorem. Okay, and you're going to need to bring your books because we're going to have to be doing problems and stuff like that. Good, we might actually have a little time. Okay, if the limit of a function is L, you have a continuous function. Remember, if the limit exists, it's continuous. And f of n, you can find the sequence associated with that function, where n is an integer, then the limit of the sequence is also L. I think we already did that there. We did it on the other side. Okay, so if you could take a function, if you take a sequence, you can model it by a function, you can find the limit of that, that's great. But you might have a sequence that looks like this, 1 over n factorial. Do you know what n factorial is? If I have 4 factorial, that would be equal to 4 times 3 times 2 times 1. Okay, Justin, you need to pay attention. It's all new material. Except this might not be if you've been in stat. Okay? Yeah, right? You did this in stat. So what's 1 over n fact? Can I model that with a function? Is there a 1 over x factorial, a continuous function? No. That's the problem. Having gone through this as many times as I have, I at least can look ahead and say, well, why don't I just do that every time? Well, you can't, because we're going to be doing factorials, and it doesn't apply. This has to be a continuous function. So I can't find one. So I'll have to figure out how to do the factorials differently. Actually, you can just make the list there. But when I add them up, the question is going to be, you know, there'll be a question there. Example 5. Is that sequence convergent or divergent? Here's what I do when I find sequences being convergent or divergent. If I don't know, I just write it out. So the first one is, first term, a sub 1 is equal to negative 1 to the 1. Second term is negative 1 to the second. Third term is negative 1 to the third. Fourth term, I'll write it until I know what's happening. Yeah. Yeah, that's all you do. So what's the sequence? It's negative 1, 1, negative 1, 1. What's it going to do? And this, by the way, is related to chaos theory, which we could get into. We could do that as an exam. We could do chaos theory. So it's keep going between 1 and negative 1. Does it have one value? Diverges. And honestly, the homework's going to look like this. There's not going to be a lot of writing. Yeah, if you don't like the writing part, you're not going to have a lot of writing. One more, and then you could start on your assignment, and I strongly recommend it. This one. Now you remember, I bet you forgot already, that if the absolute value, the limit of the absolute value of my sequence goes to 0, not just any number, then the limit of the sequence without the absolute value also goes to 0. So can I find the limit of the absolute value of negative 1 to the n over n as n goes to infinity? First off, what is the negative 1 to the n doing? We need to know what that does. I almost forgot to remind you, or tell you. It's an alternating sign. So if I write out the first element would be, first member of the sequence is negative 1 to the first, so it's negative 1 over 1. N is always a positive number. And it's positive 1, over 2. And it's negative 1 over 3. It just alternates the sign. You will see it a lot. You'll see it a lot. Okay, so this absolute value, what is that absolute value going to do that negative 1 to the n? So we're going to see that again too. It makes it positive. So I'm really only looking at this sequence as n goes to infinity of 1 over n. And we already talked about that. What's the name of that? Starts with an H, harmonic. And if you want to just write them out, you can, but I know what the limit of this is. As n goes to infinity, it's 1 over infinity, which is going to what? 0. Write out the elements if you don't know. That's all there is about sequences for today. Tomorrow there's more. But you should have your book, and you should try the problems. This is a minimum assignment. I assigned 1 through 16. That's all of them. 0 factorial, by definition, is 1. Because we have to have it as 1 when we get into some later things, so we can define it that way. Yes?